I want to introduce our next speaker, Alexander Sobania from Deutsche Telekom. Welcome to the stage. You will talk about efficiency platform of the future, AI-driven optimization. You are coordinating at Deutsche Telekom a team of data scientists, and together with your team, you are working on different use cases and challenges with network data. So the floor is yours.
Thank you very much. Thank you for having me here. So, as you mentioned, I'm coordinating the team. I'm not a data scientist myself, but we are trying to solve different challenges within Deutsche Telekom on the network side, not the customer side. And I wanted to ask you a short question. Did you hear about this new fancy thing, ChatGPT? No, I'm joking. I know you heard about it, you know it, everyone tried it, and probably everyone was as impressed as I was. But when I used it and when I'm still using it, it makes me think a bit, because you can basically ask ChatGPT any question you like and you get a reasonable answer. So you can even ask for the meaning of life and you will get an answer. However, within Deutsche Telekom, when we have an issue within our network, we need to talk to many, many people and look into many, many different data sources in order to understand what is actually the problem we are having. And why is this the case? So from my point of view, the answer is very simple. Basically, we don't leverage the data on such a big scale like we could. So for ChatGPT, someone took a huge amount of data, a very huge amount of data, and trained a model with it. And that's something which we do not really do on such a big scale within Deutsche Telekom. There are multiple reasons for this, actually. Well, one of the reasons is that we have many different technology domains. So you might think, okay, you have fixed, you have mobile, why so many? But in mobile, you have, for example, the core, you have the radio part, and then you have 2G, 4G, 5G, IP backbone, and so on. So I could go on and on. We have many of those domains with many different specific data sets. And the data within those domains is rather rare. So it's nothing which we can scale big actually there. The other topic we are having is within those domains, we have domain experts. And the domain experts are the ones actually who can explain us the data. And later on, if we have a solution, also help us to understand whether the solution is good or not. So their resource is quite rare, and we really don't want to bother them too much. So basically, this becomes a bit of a bottleneck if we want to implement certain use cases. So, I have a friend who told me once, when you feel bad because of a certain setup and a situation you have, it might be worth to look around to see how the others are doing in this area. And that's actually what I did. And according to analyst Mason, you can see that the other telcos have a very similar problem. So the biggest obstacle which we are facing is to get a high quality data and make it available for the data scientists. So knowing this, it made me feel a bit better, to be honest, but it didn't solve the problem, of course. So how do we move forward with this? First of all, I have to admit, even today, when I talk to people, I quite often hear the answer, it's too much data. We are generating too much traces, too much logs, it's too much, we cannot deal with it. And I think now coming back to ChatGPT, where they took really huge amount of data to train an algorithm, this is something which I struggle to accept now. So from my point of view, we need to also start leveraging the cloud more to be able to scale better. We need to introduce new concepts to avoid this bottleneck, which I mentioned with the domain experts. We need to make sure that our data scientists can work on their own without bothering the domain experts too much. And we can do this by focusing on certain platforms and leverage them much more. So how do we work today? Today we have three main approaches when it comes to AI use cases. We have the data-driven approach, which means basically that we talk to people who have the data, to the domains, like the core or the radio, 2G radio, for example. They know the data, they help us to understand it, they give it to us, and we can start implementing it, work on our use cases, and they help us to deploy it afterwards. That's one thing. The other thing is the product-driven approach. So here we have many, many vendors on the market who have very good solutions and products which help us to solve certain problems. We talk, of course, to the vendors, we look at the products, and we quite often have actually similar problems which might get solved with a product, so we apply them. Pretty straightforward. And the third thing is the use case-driven approach, where people have ideas how we could improve certain things. People have ideas how to reduce the costs or improve efficiency and maybe even generate some business. This is the use case-driven approach where the idea is first, and then we start to look for the data which we need to implement for this use case and discuss with the domain experts how to leverage and implement it. And to be very honest, with a team of data scientists, my favorite approach is the data-driven one. However, the biggest value add for the business we have with the use case-driven one, because there we know, okay, we can potentially save some money, some really big bucks if we implement it. So how do we get from this data-driven to the use case-driven? And I think for this, it's important to understand how our team works. So data scientists know that basically majority of the work they invest is into collecting the data, cleaning it, normalizing it, the data engineering part. This takes a lot of work. Then comes the data science parts, which I don't want to diminish it, but this is not the biggest part of the project. It's rather a small one, actually. And once we have this, then the implementation starts. And this is, again, a very intensive work, which takes a lot of time. So with the data-driven approach, actually, we focus on this part where we get the data, we do our work, and we hand it over so that people can implement it. And that's the one which I like most, obviously, because we can focus on the things we know. Once we have something like this in place, actually, we can then still continue working on it and develop it further. So let's say we develop something to identify anomalies. Once we have the anomalies, we can start to label them, try to understand why they are there, and use this for an automated root cause analysis. And once we have this in place, we can even start to think about predictive maintenance and how to solve things before they appear. So this is something where we today already work on and which we, of course, will proceed doing. But again, we want to move to the use case driven. So how do we get there? We need to implement new features, actually. First of all, make the data more available. And here I'm not talking about any magic box which needs to be invented. There are concepts like publish, subscribe. So if we really would use it properly and everyone would publish his data, it would be much easier for our data scientists to subscribe to it and leverage it. So sharing is caring. Unfortunately, not everyone cares. But we are getting there. So this is something which we need to scale. The other thing is I mentioned the domain experts. So making the data just available doesn't solve anything. We need to understand it. How do we get there? If we put the information about the data into catalogs, we don't always have to bother the experts about it. Our data scientists can work much more on their own and try to understand the data based on the information which is available. So we need to leverage the catalogs much more. And the third thing is actually to start label the data. I mentioned the topic with the anomaly detection. So how do our data scientists know whether it's really an anomaly or it's just a normal behavior? They don't. So we need the domain experts to do this. But we don't want to ask them every time. So if they manage to label the information on their own and store it for us, we can reuse it. We can improve the algorithms, and we can use this later on for the root cause analysis. And then, last but not least, I mentioned improving the algorithms. And when I talk about improving the algorithms, of course, we need to have something in place which helps us to improve them in real time. So we don't want to have every time a POC and redo the whole thing when we have a better algorithm. We need MLOps tools which are there on the market to move forward with this and have this quickly implemented. Something which monitors the algorithm, where we see there is a discrepancy, which can be then improved by retraining the algorithm, for example. So those are the things which we have in mind when we talk about a new platform and ways forward. How would it help us? So I think one important part here is that today we quite often do the same things with the same data. We have many teams working on it, and then we start again, collect it, normalize it, clean it, different use case, different approach. I think we could, if we have a much wider approach with publishing and subscribing, we could do it once and leverage it multiple times. So that would not only save energy, but also make it easier for our teams to work. Another example of a benefit for such a platform would be a use case which we have. The use case is around energy saving. So our radio towers are usually dimensioned in a way that we have more capacity than we need. Of course, to be sure that you have the best performance whenever you are in a radio tower. But for example, during the night, it's not needed. So what we can do is we can switch off the extra capacity to save some energy. The problem is when you come back as a customer and want to use it, you don't want to wait until we switch it on again. You want to use it when you are there. So what we are doing is we are predicting the load on the radio side and switch it off when we know it's not needed and switch it on before it is actually needed so that it's there when customers are coming to the radio tower. And this is something which we do already today, but we could scale it much, much wider if we would have such a platform in place, which would enable us to do it for multiple vendors, for multiple countries, without redoing the whole procedure again. And last but not least, if we have a platform which is more generic, we could replace the infrastructure below. And for example, this is really coincidence. We started to do something with quantum computing to see if we can leverage quantum computing to improve the radio planning. So we have to do quite often a calculation for the whole German network regarding capacity planning, for example. And if we leverage here quantum computing, we can be much, much faster and parallelize it much, much more. So these are examples where a platform would help us and we could move much more to the use case-driven approach, which I mentioned before. So what now? Of course, we are not able to answer the question, what is the meaning of life with this? And we don't want to. But keeping in mind what we heard during the opening session, that there are many policy makers with a lot of concerns. The thing I'm concerned about actually is that we are falling behind, that we don't leverage the technology fully. And I think for this, we need actually our freedom to do so. And I think we can use now this ChatGPT momentum to leverage more the technology and improve our networks in a more efficient way for our customers. Thank you very much.
Yes, thank you. Also from my side. And we have now a couple of minutes left for questions. And I ask you again first if there are some questions from the audience. First one.
So regarding your first question, the data as such, as I mentioned initially, we have really many different domains where we can take the data from. And depending on the domain and the vendor, it differs. So let's say from the radio, we have KPIs, we have trace files, we have logs, we have event tickets. So there's a variety of data sources we are looking at. And unfortunately, it differs from vendor to vendor and from organization to organization. We have data which is coming directly from the RAN. We have sometimes some abstraction layer on top, which is collecting the data and feeding it to us. And we have different sources, basically. So I cannot generalize it, answer it in general. And regarding your second question, so actually this energy saving topic is something which we developed in-house, where we do the prediction on our own with algorithms. And as a first step, we do the prediction. As a second step, actually, we are looking now into reinforcement learning, where we can improve then, the results by observing the KPIs of the radio and the impact our prediction had and actions.
More questions?
The biggest one, huh? That's good, because I see multiple challenges, and to be very honest with you, one of the challenges which bothers me most is how do we motivate people to share the data? I mean, if there is no immediately a business impact, why should they? Why should they put effort into pushing data into, let's say, Kafka, if there is nobody telling them after this you can save so much money? So this is actually the biggest challenge I have where I'm struggling with.
Further questions? Then one from me, following up on your question, do you have already, or how do you proceed in tackling those main questions? So what's the way to get closer to solving it?
One way is, for example, to have this use case driven approach. So if we have a use case where we can show that there is some benefit for the domain or the business owner, then it's of course easier to get them motivated to publish their data and make it available. However, it's not always the case, and it's really hard to do explorative work if you need to come up with a use case every time and explain the business benefit. You cannot do it when you want to explore something. So the use case driven approach is actually the one which motivates the people to share the data, but it would be better for us, of course, if it's there before we have the use cases even.
Thank you. We have still 1 or 2 minutes, but if there's no question left, I'm sure you will be around as well.
Yes.
At Cosmos. So then, thank you again very much.